So hello, my name is Cassiano and I'm here to present my master's research, which is about the impact of the spatial rainfall variability on the quantification of flood hazard and exposure. So the main introduction here is that the main problem that we identified is the fact that natural hazards, they cause lots of human and economic losses. And in this context, it's very important for us to be able to quantify the elements of the risk equation that we talk about: exposure, vulnerability, and about hazard. And in this context, we also want to understand the uncertainties related to these. So I wanted to focus on the uncertainties related to the space-time structure of rainfall. So the main question in this case is to which extent the assumption of spatial rainfall variability, it impacts the quantification of flood hazard and exposure. And to do this, I first started identifying some data sources that we could use for rainfall. So this includes the gauge products, but also satellite-derived rainfall. And here we adopted two data sources, the GSMAP and the iMerge. And finally, we tried to adopt some merging techniques to combine this gauge and the satellite information. After this, we went to do some validation of these rainfall products, so we could select some optimal product, and we could develop two scenarios of rainfall, one that is the spatially uniform and one that is the spatially variable. With these scenarios, we use this then as an input in the open leasing hydrological model, and finally, we could assess the impacts on flood hazard and exposure. To develop this analysis, we conducted a case study in the Itajaí-Açu River Basin. This is in southern Brazil. It's a large catchment area, around 15,000 square kilometers. And then we start with some results. So the first results that I actually found out was regarding the validation of the satellite products. So we did this complete validation for different aggregation levels, daily, 3-daily, and monthly rainfall, of a total of 11 products, including gauge, satellite, and merged gauge satellite. But we also analyze in terms of the rainfall intensity classes. And after this, we could select the most optimal product, and we could develop these design storms. These hypothetical storms related to a probability of occurrence, and then we developed this for 4 different return periods from 2 to 25 years. And again, we developed one design storm representing a spatially uniform rainfall and another one representing a spatially variable. So finally, we could adopt these design storms in the hydrological model, and you could evaluate how they differ in terms of the quantification of flood hazard and exposure. In these graphs, you have information on flood hazard and exposure for each subcatchment in the area, and the bar charts on the left, they represent the spatially uniform, and on the right, they represent the spatially distributed. So actually you can see how much we could evaluate in the discussion, how much it changed when you actually adopted different rainfall scenarios in each subcatchment and also according to the water depths. So the main conclusions that we had with this analysis, first of all, is that the merging techniques, they actually could increase the accuracy of the rainfall products with some limitations, but they showed to be promising. The GSMAP satellite product, it actually overperformed the iMerge for the case study area. In general, in this study, we presented a methodology to validate these rainfall products that can be replicated in other areas, and also we presented a framework to generate the spatially distributed design storms. And finally, we identified that the flood hazard and exposure, they were actually sensitivity to the spatial rainfall variability, but that this depends a lot on the scale that you are analyzing, which area of the basin, which water depth you are analyzing. So it's very important that we are actually able to narrow down this analysis in future studies to be able to produce more conclusive studies about our research. So thanks so much.